Hello friends, in this video we will analyze a chain that is kept on a sphere. So the question says, a chain AB of length L is placed on a smooth spherical surface of radius r with one of its ends attached to a fixed point P by a thread as shown in the figure. So we have to find the acceleration of the chain when thread is burnt. So what are the things that is given in this problem? So basically, in this case, we have a sphere and the radius of this sphere is given. So radius is r. And on this sphere we have a chain. So this is the chain and the length of this chain is given and this length is L. And one point, top point is A and bottom point is B. And this chain is basically connected to point P through a thread. Now we have to find the acceleration of chain when this thread is burnt. So in this problem we have been given length, we have been given r, and let's say mass is also given. This may not be required in the final answer. We can also say this angle is phi, that can also be given because phi is equals to L by r. So in this problem phi is also given. Now question is, if you burn this thread, this whole chain will start going in the downward direction. Now, is the tension at any point, so at tension at this location, tension at this location and tension at this location in the chain will be same or it will be different? So if you think a little bit, you will find this has to be different, because if you consider this section, then this portion of chain is trying to pull this section. Now, if you consider different section, for example this section, in that case this portion of chain is trying to pull. So tension is not constant. We can say in this case tension is changing with theta. So I have one observation, that is tension is varying. So tension is not constant. So let us try to analyze a small mass. So what we will do is we will take a mass dm here and we will analyze this mass. So a small mass dm at angle theta. So let us say here I have this diagram. So at theta, so this was the point, now this chain has cut, or this thread has cut, and this is another point. Let us say at angle theta, we have a d theta, and this is a small or differential chain, and mass of this portion is, let's say, dm. So dm will be what? You know the total mass is m, and per unit length mass will be m by L, and this will be r d theta. So this is r and this angle is theta. This means this will be simply r d theta. So this is r d theta. So this will be m by L times r d theta. Now, as I said earlier, the tension at this point and tension at this point will not be same. So let us say this side the tension we have is T and this side we have tension is T plus dt. Now what are other forces that is acting? So if you see, so in this case another force is mg that is acting in the downward direction, and mass is a small m, so a small dm, so let's write as a dmg. Now what will be this angle? Since d theta is very small, so this angle will be theta. So since this angle is theta, this angle will also be theta because d theta has no meaning. D theta is very small. Not this angle, basically this angle. So this angle is theta, then this angle will be theta. So this angle will be basically 90 minus theta. So component of DMG in this direction will be DMG sine theta. So now if you balance forces, then you can say T plus dt minus T minus dmg sine theta is equals to 0. This means from here I can write dt is equals to dmg sine theta. So if I integrate this, I will get the total tangential force. So what is this dt? dt is tension, which is basically a small or infinitesimal tension force or infinitesimal tangential force. So if I integrate this, I will get total tangential force. So if I integrate this, basically first I have to convert in terms of theta. So let us say dt will be, and dm is what? This one, m by l times r d theta and times z times sine theta. Now I can integrate both sides. And tension for tangential force, limit will be 0 to t. And then this side theta will be 0. So this is the top theta, that is 0. And 0 to phi, and phi we already calculated, that is L by R. So final angle is L by R. So this is 0 to L by R. So this side we will have T is equals to M by L. And let us take ZR common. Then we will have simply sine theta d theta, 0 to L by R. And integration of sine theta is minus cos theta. So we can write it here. T is equals to M by L GR minus cos theta, and limit will be 0 to L by R. So from here I can say tension is equals to mgr by L 1 minus cos theta, and cos theta will be L by 2. So cos L by R. So this is not 2, this is R. So this is L by R. So this will be the final tension, or this is the tangential force. So this is the tangential force. Tangential force. So tangential force now I know. Then I can calculate tangential acceleration. So 1 minus cos L by R. Tangential acceleration will be force, tangential force, let's call this as Ft. So tangential force divided by mass, this will give me tangential acceleration. So this will be simply gr, and this is L, not T. So gr by L, m cancels out, so 1 minus cos L by R. So this will be tangential acceleration. What about radial acceleration? Since this thread is just burnt, so chain will not gain any velocity. So this is just started to move. So this means each link of chain has a zero velocity. And we know radial acceleration is v square by r. Since velocity is 0, radial acceleration is 0. So what is total acceleration in this case? Radial acceleration whole square plus tangential acceleration whole square, and then you have to take root. Radial is already 0, so total acceleration is simply tangential acceleration. Now a question for you. In this case we said that the surface of contact between chain and a sphere is smooth. Now let us say this is a friction surface. So you have to find what will be the minimum friction of coefficient so that Even if we burn the chain, we burn the thread, chain will not fall or chain will not start moving. Chain will stay on the sphere. So for that purpose, what will be the minimum friction coefficient, mu value? So let us discuss how will you solve this problem in the comment box. And I will see you in the next video. I hope you enjoyed this video, you like this video, and if you like, please share with your friends and subscribe to my channel. Thank you.